Okay, we're going to do one example of definition of a limit, the Epsilon Delta method. And there are other videos out there. Krista King's a good one. Patrick JMT is a great one. And there are others where they will show you the proof. I'm not going to take the time to show you the proof, but I'm going to show you the kind of the math of what you'll be doing on a practice problem. Okay, so the definition of a dilemma, limits are a dilemma, of a limit says that if 0 is greater than or is less than the absolute value of x subtract c less than delta, then the absolute value of the function subtract the limit will be less than the epsilon value. And essentially what that is saying is, if you look at this example of this negative cubed graph, right? As we get really, really close to this C right here, infinitely close, think really, really close, those pieces are called the deltas. Well, if you follow, here, let me change that to this color. If you follow those deltas up as it gets really, really close to that height and then go over, it falls really, really close to the limit, and we call that epsilon. Okay, so I'm going to show you what that looks like for a problem. I've restated, not really the theorem, but the setup of the epsilon delta method. And here's the big idea. You could choose how close you want to get. Do you want to just get 1/10 of a point? Well, that's not that close. 1/100th of a point, 1,000th of a point, close to the limit. You choose the epsilon and then find the delta. And that's what we're going to be doing here. I believe I set this up to the epsilon being this. And here's the function. F of x, or the limit as x approaches 2, that's the c value, of the function 2x subtract 1 is equal to 3. And if you use substitution, you can figure it out. Substitute 2 in there. 2 times 2 is 4. 4 subtract 1 is 3. So we know we have a limit. That's correct. But this is how you go ahead and find out how close. If we're going to be this close with the epsilon, how close is that for the delta? So we go ahead and set it up using this information. We take the f of x, subtract the limit, and we're going to set that less, the absolute value of that, less than the epsilon distance. And then we're going to simplify this. -1 subtract 3 is -4. And then both of these share a 2. So when we pull out a 2, it's the absolute value of 2. And then the absolute value of 2 is 2. So we can just rewrite that as times 2. And then we're going to divide both sides by 2. And then once we do that, this is the delta that we'll be using. And I know it looks like you're done, but we're going to go ahead and finish this. Now you just have, an absolute value inequality. So when we remove the absolute value bars, we have two things we're going to be working with. We have this expression right here is less than 0.0005, and it's greater than negative 0.005. So when we add 2 to both sides, this x right here, the x value falls in between these two things, but our delta we already found, 0.0005. All right, that's it for delta epsilon. Some calculus courses cover this. Some of them just cover it very little. We'll practice it a bit, but that's it for this one.